On? Is that good? Voice check. Nah. Okay, so I have my video guy here. I imported him from Sweden. We simply call him Mr. IKEA. Okay, so I have a Swedish videographer. Excellent. Now, this lab is going to be the production of magnesium oxide. How do you think I would produce magnesium oxide? What two chemicals do you think I would need in order to produce magnesium oxide? Anybody? Yes?
Magnesium and oxygen?
Magnesium and oxygen. Well, here's the magnesium. I'm going to pass a piece of this around. Magnesium is, looks like kind of like aluminum foil, but much more rigid. I'm going to pass a piece of this around. This is magnesium metal. I'm going to come over here and I'm going to give you a little bit of a look on this. This is magnesium metal. Okay, can you see that?
No. Up and to the right. Yeah.
To the right?
Up.
Up?
Yeah, there.
Is that good?
Yeah.
That's magnesium metal. Can you see how that, does it come out?
Yeah.
Where you have the texture of it? Okay?
Down.
Yeah, there.
Good?
Yeah.
Yeah? Okay, that's magnesium metal. Okay? I'm going to pass that around. Now, can I show the oxygen? Where's the oxygen, Anna?
In the
Everyone.
Thank you very much for answering that question, Anna. I appreciate that. Yes? You just went, yeah. What? I mean,
in the air.
in the air. Yes, that's correct. It's in the air. Can you see it? Can you see the oxygen?
Kind of.
You can see the oxygen, Aaron? Okay. All right. As soon as you get back to the States, I would find a doctor, okay, and tell him that you see oxygen molecules, okay? You know? You also see elephants periodically walking down the street? Excellent. Okay, now, so we're going to take oxygen and magnesium and combine them. All right. Let me just burn a little oxygen. A little magnesium metal. I just want to burn a little bit of it, okay? Just to show you the actual reaction that's happening. And what I'll do is, girls, thank you for listening. And what I'll do is, I will show you what this looks like. Okay? All right. Here we go. The first thing you have to understand is safety. Okay? You have to wear goggles. It's very important. You know that box over there? The one that's with the blue tag there?
Yeah.
Yes. You understand the color blue? Okay, so that's the one. So you want to bring that to me, please? Thank you. Excellent. Rashid looks so professional today. He has the most amazingly tied tie. Okay? This is the wrong box. Where's the right box? Where are the goggles? Where are the goggles? No, that's not it. Oh, there they are, right there. Sorry, they're not in a box. Bring me that tub, that plastic tub. Thank you. My apologies, Rashid. I understand the color blue, but wrong box. Okay, so these are the goggles. Okay, so these are the goggles you use. Anybody ever see the movie Halloween? Jason in the Mask? Well, this is what Jason actually used, and he painted it white. Okay, so yeah, this is what he used. I got to take my glasses off. Okay, and this is what he used. Okay, so
He looks like Bane.
paintball. This is for paintball. Is that what these are for? Okay. So what you want to do is, because you're gonna die of suffocation, you want to take these off, and you'll see that this one comes down and these go up, so it's a little weird. So you got to kind of push it up like that, and then this comes down, and then push it up like this. Just got to wiggle it around. Don't break it. It'll come out. Okay. So you can see how that's a little hook there. Okay. And then these go. These are hooked down, and this is up. Okay. And then you have your goggles. You got to wear your goggles when you do the lab, always. First thing. Okay. Now the next thing is that you cannot. Would you touch something that's really hot?
No.
What do you think? Is that a good thing to do? Touch things that are hot? Yeah. Like what you do is if you put a pot, Rashid, thank you very much for listening. I appreciate that. Shockwood, he's trying to tell you something, and thank you for ignoring him. If you're going to put a pot on the stove, are you going to take it off the stove and put it on your hand? No. Are you going to take your hand and put it in the flame and hold it there until you smell cooking meat? Maybe add a little curry, okay? Some saffron, maybe a little sea salt, yes? Add a little water so you get that meaty flavor. What do you think? A little crazy? Yeah, I think so, okay? Don't do that. So do you understand that? Do you understand that safety is almost entirely in this level of chemistry, common sense? If I gave you an Erlenmeyer flask, and it said on that Erlenmeyer flask, acid, would you do any of the following, true or false? Okay. Drink the liquid in the Erlenmeyer flask, true or false?
False.
False, excellent, I feel better. No kidding around here, this is serious stuff, okay. Take the acid, put it in your hand and splash someone's eyes. Would you do that?
False.
No, you would be false, excellent. Tell the teacher, thank you for labeling it as acid, true or false? Yeah, you would do that. Because what would happen if you saw an Erlenmeyer flask and it wasn't labeled? Would you say to yourself, that's very interesting, let me taste that to see what it is?
True.
Would you do that? Okay, remember I said to be serious. I'll give you detention until you're 50. Understood? Good. So, true or false? Safety is common sense. Are you going to run around the lab with a meter stick and chase your classmates?
False. False.
Thank you very much. I hear some mumbling. I don't like mumbling. Unless it's me mumbling. Okay, so a lot of it's common sense. Let's learn how to light a Bunsen burner, okay? Now, this is kind of like, if you've ever heard of a carburetor? No? Heard of a carburetor? What does a carburetor do? Carburate? Really good, Aaron. Excellent. You sound like a high school student, simply rephrasing the question and submitting it as the answer. Okay, so what is a carburetor? What does it do? It's to mix what?
I thought it was the flame.
No, that's not the carburetor, but you're close. The carburetor is a chamber that mixes the reactants in a car. They used to have carburetors in the old days. And what it did was it allowed the gas to come in, the gasoline, the petrol, and it mixed it with atmospheric oxygen in just the right measure so that it would burn, right? And that's kind of what this does. This allows the air to come in. Do you see? Let me take this off here. Do you see this? Can you see that?
Yeah.
Does that come out? See how that little hole there? Well, the gas is coming this way and out the flame, and this allows the oxygen to mix. Now, if I have it open this much, what do you think is going to happen? It won't light. Yeah, that's right, because it'll be too much oxygen. You don't want that much oxygen, so you have to close it so that it's a perfect flame. Does anybody know what color the flame should be? Blue, like almost like a cyan blue, a light blue. Yes? Okay. Well, let me tell you something. Not only should it be blue, but there should be a double cone, and I'm going to show you what that means. There's going to be an inner cone and an outer cone. And what you do is you're actually heating the object with the inner cone. Yes? Let me show you what that means. So I'm going to hook this up to the burner. Watch how I do this. If you wear glasses, you're going to need contacts. It's going to be very difficult to do this without. We're going to have to find you goggles that work. Okay? So you're going to have to see me, Shuckwood, okay? It's really important. Okay? All right. So, all right. All right, that's on. All right, here are the matches. We don't have any strikers. We use matches. Thank you, Michael, for paying attention. I appreciate that. I know that it's getting very dramatic and you're waiting for the plot to thicken. Okay? Turn it on. Okay? It's on. You can hear it. Okay? It's blowing the match out. Can you see it? Can you see it? Okay. All right, watch. See that flame? Can you see that flame? Is that better?
Yeah.
Can you see the flame now? Yes? Can you see it?
I can't see it.
You can't see it? Turn off the lights, please. Okay, you see the orange up top?
Yeah.
Okay. You see that orange? You see that?
Yeah, you see it now.
See that orange? Okay, stay up there, so I want you to turn the lights on in a second there, Rashid. Thank you for being up there. So you see that orange? That means that it's a dirty flame. It's not getting the proper amount of oxygen. Okay? So what you do is you let a little bit more oxygen in. See that? That's perfect. It's a nice large flame, and there's an inner cone and an outer cone. You never want to do that. Okay? You never want to touch the flame. Okay. So do you see that there's an inner cone and an outer cone? You see that? Yes or no?
Yeah.
Okay, turn the lights on, please. Okay, what you're actually doing, yes, Shuckwood.
Why did you tell us not to put our finger in it and then you put your finger in it?
Because I was trying to demonstrate something and I realized that I'm giving you a bad habit and I don't want you to do that. Do you understand?
Yeah.
Are you sure?
Yes.
Would you ever put your finger in the flame?
No.
Excellent answer. So what you're actually doing is, could you turn the lights off once more, please? Thank you. I don't know why, it's just so very bright in this room. Turn the lights off, I said. Oh, is somebody doing it? Okay, thank you. All right, so this is what you're heating, right? Now do you see that the inner cone is right there? Do you see that? That it's right under the pot that you're boiling? You see that? Yes or no? Anybody not see it? Okay. You see? Right there. All right, can you turn them on again there, Professor? Thank you. So in other words, it's right. Does this help when you go like that? Does that help?
No.
Not at all? Okay. All right. So you see it's like right there. It's right underneath the crucible. Okay? So I'm going to turn this off for a second, okay? Okay, now. So that's what you do. That's how you light the flame. Now, what I want to show you is something, and when you burn magnesium, it's like the old photographers, when they used to use powdered magnesium to flash, okay? I'm going to show you the actual reaction that's occurring. This is the actual reaction that's occurring, okay? Let me take this off. The crucible tongs, these are called. Clay triangle. Clay triangle. Can you see it? Clay triangle. Okay. Ring. Ring. Got it? Ring stand. It's called a ring stand. Okay? All right, so, ouch. So I'm going to put this here. Okay? You've got to be careful what you touch. It's really amazing. You can burn yourself very easy. I've been doing this for my entire adult life, and I still forget what's hot, what's not hot. Okay, so you don't want to look directly at the flame. This is going to burn white hot, and it looks hot, and it is actually very hot. So I'm going to put it right at the top of the inner flame, and you see the white. You see that? Don't look directly at that flame. And you'll see that it's burning very hot. That's the actual reaction that you're doing. Now, it's kind of amazing. Once that goes out, it cools off extremely quickly. Clear? It cools off extremely quickly. Okay, what I'm going to do is, I'm going to put the powder in my hand. Okay, and it's really not hot. Okay, no, you don't want to do this. Okay, but I just want to show you how it changes. I want to show you how it changes. This is the powder. You see it? Can you see it? Yeah, you see it? It's like very, very fine ash. It's a very fine ash. Do you see it? Can you see that? Yes? Very fine ash. Okay? Yes? Very fine ash. That's magnesium oxide. You get it? Okay. So, this is the lab. I'm going to go through this very quickly because how many people here are very smart? Everybody is. Everybody can do this. Fatima, you are brilliant. Okay? Everybody is. Taylor, say after me. I am very bright.
I am very bright.
Excellent. Okay. So, triple beam balance. We don't use electric balances in here. Electric balances are for babies. Electric balances are for non-chemistry people who don't care about accuracy and precision. Understood? Okay. All right, so this is a balance. All right. The first thing you're going to do is, you're going to make sure that this is zeroed. Okay? How do I zero something? Can you see it? Okay. See how that's not zeroed? It has to be heavier. Okay. Well, it's going to be difficult to do this that's not on a table. Okay. But what you do is there's a little knob here. And the little knob, can you see the little knob? See how you turn it? If I turn it this way, backwards, it comes out and it makes it heavier. If you turn it in, it makes it lighter. Okay, so that's how you're going to adjust to make sure that it's zeroed. Clear? You don't play with this knob at all. Understood? Okay? All right. So, here is the balance. Okay? Yes? All right. So what I'm going to do is, I'm going to zero it. First thing I'm going to do. Okay? Make sure these are all in zero. And then I'm going to say it is zeroed. Perfect. Take a piece of paper. You don't put chemicals directly on this. Okay? Solid chemicals, you can use a piece of paper. Other chemicals, you're going to need something more durable, like a plastic or a piece of, or glass beaker or something like that. Okay? Or the crucible directly, you could do that. Okay? So, this is just what I like to use, something that keeps it. So you want to use this, but you want to make sure that you find the mass of this. Clear? Does that make sense? So you're going to find the mass of this. Okay? Yes? So the mass of that. So then you move this, and you find the mass of this. The mass of this is 1.39 grams. Then what you're going to do is, you're going to take 5 centimeters of this. You'll take 5 centimeters. Okay? 5 centimeters. About 5 centimeters. It doesn't have to be exact. Okay? Yes? Roll that up like this. Okay? And put that there. Now find the new mass. Total masses. Right? Find the new mass. Actually not enough to... You know what? You're going to have to put even more on there because it's just not registering. Okay. should redo that. Takes time. Yes? But you got to make sure that's exactly on the line. See why people don't like to use triple beam balances? But they're very accurate, extremely accurate. Okay? So then you write the mass down. I got the mass to be 1.20. Okay? It's only going to go up a little bit, so you got to get it back down to the 0. .60. Clear? Right? So you write those masses down. So the mass of the paper plus magnesium. Then you take the magnesium and you put it in the crucible. You put the lid on the crucible. You take your tongs. This may still be hot. So you want to put your tongs and put your clay triangle on here. And then you see this? See this? You take your crucible and put it on the clay triangle. Put on your fire. Make sure that the Bunsen burner is stable, because this tubing is very rigid. So you want to make sure that it's nice and it's not moving. Okay, everything is nice and stable. You take your match and you light your Bunsen burner. Turn it on all the way. When these two wings are parallel with the flow of gas, that's on. When they're perpendicular, it's off. Okay, you got it? Okay. Okay, so now it's cooking, and you leave that on for, say, 2 or 3 minutes until it gets nice and hot. Then what you're going to do is you're going to take the lid and go like that. Okay. Now what I did was I made a mistake. And it's a mistake that I purposely made because you're going to make the same mistake, but you can't. All right. What did I do wrong? What is it? My goggles have to be on. That's very good. Excellent, Sultan. What else? What else did I do wrong? What else did I do wrong? Yes?
You didn't leave in the beginning, you didn't leave
You got to speak up.
didn't leave the top of the crucible open so it could react with the...
Well, yeah, the air's got to get in there, but you want to keep it on for a little bit until things get a little hotter. And then you want to leave it off a little bit. Okay? But you want to make observations. I found the mass of the paper and the magnesium. Yes? So what can you find out now? The mass of what? The mass of the magnesium, correct? Can't you? Okay. You have to find the mass of the crucible and lid before you put the magnesium in there. Do you understand? Yes or no?
Yeah.
You have to find the mass of the crucible and lid before you put in the magnesium. It's a very, very, very common mistake. Understood? Because how are you going to find the mass of the magnesium oxide? It's a powder. It may stick to the inside of the crucible. It would be very difficult to take all of the powder out and put it on the balance. Do you want to put a hot crucible on a paper towel? So what do you have to do with the mass of the paper towel and the mass of the magnesium? Find the mass of what? Just the magnesium. Then you can take this off. This you can put on a hot crucible on that stage. Clear? Okay. So then you heat it, it reacts. I've opened up the crucible, closed the crucible. You want to make sure everything is reacting. Nothing has reacted yet, so it's going to take time to react. Okay? Yes? You want to take notes and observations, etc. You're going to see smoke come out. You're going to see the reaction will take place, but it takes some time. It's got to get really hot, very hot. Clear? That's the lab. Then what you do is, you let it cool. Once the reaction has cooled, you find the mass of the crucible and lid, and then you find the mass of you subtract the mass of the crucible, lid, and magnesium oxide. What do you subtract from that? The mass of what? The mass of what? What do you find? You find when this cools, when its reactions occurred and this cools, you find the mass of the magnesium, the magnesium oxide, the crucible, and the lid, correct? In order to find the mass of the magnesium oxide that you produced, what do you subtract from the mass of the lid, crucible, and magnesium oxide?
Lid crucible.
The mass of what? Think, everybody. I know it's first period. They're very tired. What do you subtract from the mass? Yes? Anna?
The lid and crucible.
The lid and crucible. The mass, let's say it as if we know English really well, and I know you do. You would subtract from the mass of the crucible, lid, and magnesium oxide, you would subtract from that the mass of the lid and crucible. Is that correct? Excellent. You get it? Michael, thank you for participating. I appreciate that. Excellent. Don't I yell at people well? Excellent. Okay, so that's the lab. Clear? Yes or no?
Yes.
Okay, let's turn it off and we'll do part 2 quickly.